Systems, a review from Algebra 1. You have a system whenever you have two or more equations with the same variables. For example, here's two equations. They both have a y, they both have an x. Here's a system, x, y. Here's a system, y's and x's. More than one equation, same variables. Now, the solution to a system, the solutions of a system are any points, ordered pairs, that work in all equations, which means if I plug the two numbers in to this equation, it's equal. I plug the same two numbers into this equation, and they're also equal. There are three possible solutions. Solutions. That's nice. Little typo there. First, we have where the two lines intersect. So if I graphed this equation and this equation, we could find the solution 2, 1, 2, 3. 2, negative 3. 2, negative 3. Second situation. No solution. No solution means that the two lines do not intersect. And if two lines do not intersect, they are parallel to one another. Situation 3. This is where you have two equations, but you only see one line. That means that they're on top of each other. They're coinciding. And they're called coincidental lines. Coincidental lines. And since they touch in every point, the solution is infinitely many solutions. Now to solve these, obviously from above, one method is by graphing. And then find the points of intersection. Sometimes there might be just one, and sometimes there might be two. An example of two real quick would be when you have a parabola and you have a line. As you can see, they intersect in 2 points. Here we would have two solutions. Okay, another method, if you plug the equations in and look at a table, find the points that they have in common. You can do this by hand or with a calculator. Third, substitution method, which is what we learned on the back. Substitution method. Elimination method, also we learned on the back how to do the elimination method. And finally, using matrices, which we will learn a little bit later on. So, there's your introduction to systems.